Hello everyone and good morning to you. Welcome back to the good stuff we have been doing. Today in this video we're going to try to evaluate this beautiful integral right here. It says this is the integral from 0 to infinity of x times tan inverse of s divided by 1 plus x to the fourth dx. Okay, one way to do this is that notice that because we have a tan inverse, it is difficult to make substitutions here. You have to keep that in mind. For example, if you try to take, let's say u to be x squared, okay, this is fine, but then you end up with tan inverse of the square root of u when you do everything. So which should not be too great for us, because tan inverse of square root of u is difficult to work with. So as it is now, it is difficult to make substitutions. So first of all, since it is difficult to make substitutions, that tells us that before we could make any progress here, we must get rid of this tan inverse. Okay, so to do that, we'll start with this. We notice that the integral from 0 to infinity, it would be integral from 0 to 1 plus the integral from 1 to infinity. So we're going to write this whole I to be the integral, which is integral from 0 to infinity of x times tan inverse of x all divided by 1 plus x to the fourth dx. We're going to split this into two intervals from 0 to 1 of x times tan inverse of x all divided by 1 plus x to the fourth power. Then this is going to be plus the integral from 1 to infinity of x times tan inverse of x all divided by 1 plus 1 plus x to the fourth power dx. So next up, what we're going to do here is that for this second integral, we're going to take x to be 1 over t, so which means that dx would be negative 1 over t squared dt. So you're going to have the integral from 0 to 1 of x times tan inverse of x all divided by 1 plus x to the fourth dx plus, so now when x is 1, t is 1, so this is integral from 1, but when x is infinity, t would be 0, so that would be integral from 1 to 0 of 1 over t tan inverse of 1 over t all divided by 1 plus 1 over t to the fourth power times negative dt over t squared. Now when all is said and done here, if you simplify this, you would end up with this is the integral from 0 to 1, integral from 0 to 1 of x times tan inverse of x all divided by 1 plus x to the fourth power plus the integral from 0 to 1 of x times the tan inverse of 1 over x all divided by 1 plus x to the fourth power dx. So like here, I simply change x to t after doing the simplification here. So you would end up with the integral from 0 to 1. Since they have the same limits of integration, it will be x tan inverse of x plus tan inverse of 1 over x all divided by 1 plus x to the fourth power dx. Now we know that the tan inverse of x plus tan inverse of 1 over x actually equals pi over 2. So essentially you would have the integral from you have pi over 2 times the integral of x over 1 plus x to the fourth power dx. So one good way of doing this is that I have a follower on Facebook who suggested that here you take u to be x squared. So in that case, du, so this is 0 to 1, du will be 2x dx. So you would end up with pi over 4 times the integral from 0 to 1 of du all divided by 1 plus x squared dx. And this way, it will be equal to the pi over 4 times the integral from 0 to 1 of, okay, not even integral from 0 to 1, this is equals to tan inverse. So this is equal to pi over 4 times tan inverse of x from 0 to 1. So that would be pi over 4 multiplied by pi over 4, and that will be pi squared over 16. Now, the reason why I mentioned to this point that a Facebook user suggested this is because in my original solution to this problem, I was thinking that okay, I was thinking towards beta integrals, because I know that the integral from 0 to infinity of x to the s minus 1 over 1 plus x dx is pi over sine pi s. In my mind, I was thinking I was going to do this via beta integral, but because the limit is from 0 to integration, I ended up using series technique here. But this one is much more shorter and a better solution, so that is why I'm using it in this video. So thank you for watching, and please do subscribe to the channel. Bye.